Okay, so let's begin by discussing what is linear momentum. So linear momentum is going to be given by the letter P, and it is inertia in motion. So that's going to be its definition. And another name for inertia is going to be mass. So when we say that something is in motion, we say that it has a certain velocity v, and then if it has mass, then if we multiply m times v, this is going to be its linear momentum. Now I say the word linear momentum because later in another lesson we're going to learn about rotational momentum, the kind of momentum that something has when it's spinning. So today what we want to talk about is the momentum something has when it's moving sideways. Another thing to notice is that this is a vector, meaning that it has both direction and magnitude. And now this, though, is a scalar, but when you multiply these two things together, it means that momentum is a vector, so that it both has magnitude and direction. So that means that you could have momentum P going in this direction, you could have momentum P going in this direction, you could add those momentums together head to tail if you wanted to find out what the total momentum of that system is. But in today's lesson, all we're going to be considering is momentum that is going sideways. And so we're going to have it just in one dimension. Later, we will discuss what does it mean to have momentum in two dimensions. But everything that you're going to be doing today, and also if you're one of my students on the exam, is going to be linear momentum in a straight line. Okay, so what would be some properties of momentum? Okay, first of all, what would happen if your object is not moving? So if an object is stationary, how much momentum does it have? Okay, it's going to be zero, because if it's not moving, how much speed does it have? Zero. What's zero times anything? Zero. So if an object is stationary, it has no momentum. So if I was to ask you on an exam, and I say that the Queen Mary is in port and it's docked, how much momentum does it have? You might be tempted to say, well, the Queen Mary, I mean, it's really, really big ship. So it's going to have a lot of mass, so therefore it's got to have a lot of momentum. Well, no, because if it's stationary, if it's docked, it has no speed, and therefore it has no momentum. So how can we give momentum to an object? Okay, one way would be to give it a lot of mass. And so that's the Queen Mary. So if the Queen Mary, so let's go ahead and, now let's just assume that we're not going to treat the momentum as a vector. So let's just assume it's just a number. So I'm going to get rid of the bar thing. And so let's say that the Queen Mary has a tremendous amount of mass, and maybe it's only going at 1 meter per second. So it's going very slowly. Well, it could turn out that this m would overwhelm the small speed, and so then this thing over here would have a tremendous amount of momentum. Okay, what would be another way of giving something a lot of momentum? Okay, so think about a teeny tiny little bullet. So if you've got a bullet, that bullet might only weigh a few grams. So it doesn't have a whole lot of mass. So in this case here, we would put down a small m. And so how could a teeny tiny bullet like this have a lot of momentum? Well, when it comes out of a gun, it might be traveling at 100 meters per second. So therefore it would have a large velocity, and so a large velocity times a small mass could be, again, a very large amount of momentum. So just remember that momentum not only depends on the mass of the object, but it also depends on how fast it's moving. Now, I also want you to be able to calculate momentum. So here is a sample question. What is the momentum of a 50-gram ball traveling at 3 meters per second? So first we're going to write down what you're given and what you're looking for. So we're given 50 grams. Grams is a unit of mass, but it's not the official unit of mass. So that's going to be the kilogram. So first we've got to change 50 grams into kilograms. Okay, the speed is going to be 3 meters per second. We're trying to find out what's the linear momentum p. So we're going to plug our numbers into the formula, and it turns out to be 0.15 kilograms meters per second. So notice it doesn't have a nice metric unit like, for example, the Newton is the unit of force. So the unit, the official metric unit for momentum is going to be called the kilogram meter per second. Okay, so now what we want to talk about is how is momentum related to force, and we'll do that in our next segment.